Well, here we are, section 8.1, and I'm sitting here in the hospital and I'm doing a lesson on La Hospital's rule. Cracks me up. Anyway, it's not really La Hospital, but you'll want to remember it that way. It's L'Hopital. That's what the guy's name is, L'Hopital. And he's got a rule that'll help us find limits, and it'll be very helpful. Actually, he got the name for it, but it was developed by his teacher, Johann Bernoulli, and Bernoulli is that guy right there. So let's go ahead and get into it. If you've already done the pre-Chapter 8 worksheet, good job. You should have already done that and looked over it, corrected any mistakes that you might have had as well. So let's look at this limit, a limit that you've already actually been able to do by factoring the numerator and canceling with the denominator and then substituting 2 back in. But the most important thing to understand here is that when you're finding a limit as x is approaching a real number, and the first thing you should always do, please always do this, is plug it in. Substitute 2 for x, and in this case you get 0 divided by 0. And 0 over 0 is called indeterminate. It's an indeterminate form. And the indeterminate forms are the only ones where you're allowed to use L'Hopital's rule, okay? And so sometimes you get to use L'Hopital's rule when right away if you get 0 over 0 or infinity over infinity, and we'll talk about that in a minute. But for 0 over 0, you can go right to L'Hopital's rule, and L'Hopital's rule we'll get to in a second as well. But like I said, you can find this limit by factoring the numerator, canceling, and substituting 2 back in, okay? Now I have to apologize, this next slide is going to be a little bit confusing when you get to this part here. If you graphed x squared minus 4 and x minus 2, you can see that at 2, both of these functions equal 0. So when you put 2 in, they both have a value of 0. If you zoom in far enough, the curved lines actually appear linear. And this part I've looked at over and over again, and I need to look at it more and more. It's hard to understand. Feel free to pause the video and get some semblance of understanding of this. But the main thing to understand is that when you get 0 over 0, the indeterminate form, you're allowed to then take the limit of the numerator, sorry, the derivative of the numerator, and then also the derivative of the denominator, and then take the limit as x approaches 2. So in other words, substitute 2 back in to what you get when you take the derivative of both the numerator and the denominator, not to be confused with the derivative of the quotient, because we know that the derivative of the quotient is not the quotient of the derivatives. You'd have to use the quotient rule, and do not use the quotient rule when you're using L'Hopital's rule. So we can see that the limit using L'Hopital's rule here is the same limit that we got when we did the substituting and factoring and canceling. So notice here very clearly, I guess I can point to it, right, where's that mouse? There we go. So right here is the derivative of the numerator divided by the derivative of the denominator. Sorry, I didn't mean to do that. And the confusion lies for some students when they try to take the derivative of the quotient and use the quotient rule, and that'll be on a multiple choice test. It'll be one of those sucker answers that some of you, hopefully none of you, will fall for. Okay, so look at this very carefully, and this really should read, if the limit as x approaches a of this quotient of two functions is 0 over 0 or infinity over infinity, then you can use L'Hopital's rule, okay? So just because it's indeterminate doesn't mean you get to use it right away. So we can prove L'Hopital's rule kind of backwards. If you look at the derivative of f at a divided by the derivative of g at a, we can use the definition of the derivative, and working backwards, the quotient of the limits is equal to the limit of the quotient, okay? And then we can cancel the x minus a's in the denominator. We can then let x equal a, and we get f of x, the limit as x approaches a of f of x over g of x. So if you work your way backwards from this part here, where is it? Mouse is hard to find. From this part here all the way back, you get to f prime at a divided by g prime at a, okay? So that's L'Hopital's rule, and let's do a couple examples. what I don't like about some of these PowerPoints is that I didn't create them, and there's some intermediate steps here that are missing. So the first thing you should do is plug in 0. So mentally you should be looking at this. 1 minus cosine of 0, which cosine of 0 is 1. And then, so 1 minus 1 is 0 in the numerator, and you get 0 in the denominator, so you're allowed to use L'Hopital's rule. You don't have to say you're using L'Hopital's rule, you just write equals the limit of the derivative of the numerator, which is sine of x, over the derivative of the denominator, which is 1 plus 2x. When you put 0 in at that point, you get 0. Now, some people don't check it, they just do the derivative again. Okay? So you have to stop. If it's not an indeterminate form, you stop. If you just get a number, if you get a real number, you stop and you're done. If you try to continue, then you get the limit of the derivatives of both numerator and denominator, and you can see you get a big wrong answer. Okay, so you don't want to do that. So just pay attention, and this could be a very helpful rule. Okay, so please just pay attention. You can, if you keep getting 0 over 0, then you can keep using, you don't have to keep looking at this because it's going to just get confusing, but if you keep getting 0 over 0, you just keep taking the derivative of the numerator and divide it by the derivative of the denominator, and you keep substituting in the value that x is approaching. And in this case, we get, finally, after 3 times, we get, or maybe that's 4, we get negative 1/8 as the limit of that function. Okay, so you probably never have to do a problem as complicated as that. Usually it's other ones that are pretty straightforward. Okay, so this is the other one. I don't know why they group it. When I do the lesson on my own, I would group the infinity over infinity with the 0 over 0, because you're allowed to use L'Hopital's rule when you get infinity over infinity as well. So some other indeterminate forms, which I will explain how to convert these so you can use L'Hopital's rule, will be here. These are the ones, and I'll show you also when we get to class how to memorize all of these. And but for now, let's just we'll do an example for each one. Here you go. If you plug in infinity, in this case, you get infinity times the sine of 1 over infinity. Now that would be the sine of 0. So if you let x go to infinity, what you'd see here is you get infinity times 0. Okay, and now you're not allowed to use L'Hopital's rule because you don't have a quotient of 0 over 0 or infinity over infinity. But there's a trick here that you can just go ahead and rewrite that, what you're taking the limit of, as sine of 1x, so 1 over x, divided by 1 over x. Okay, and then you get 0 over 0. And then when you take the derivative, okay, we already know that, but let's show how we use L'Hopital's rule. When you take the derivative of the numerator, you get that, and so these are derivatives that when you do them quickly, you can figure out the limits pretty quickly. So you can see that the negative 1 over x squareds cancel, and when you put in infinity for x now, you get the cosine of 1 over infinity. Now 1 over infinity goes to 0, cosine of 0 goes to 1. Okay, and so that's how we use, that's what we do when we get infinity times 0. So you got to think fractions, okay? Infinity times 0, you're going to think fractions. All right. And then when you get infinity minus infinity, then you also want to think fractions as well. So the last two, this one and the last one, you're going to think fractions. If you get a common denominator and subtract, we'll get this, and I'll let you do that math. Here you get 0 over 0. Now you get to use L'Hopital's rule. Okay, you don't have to, again, you don't have to say that you are using L'Hopital's rule, just use it. Okay, it's equal to that limit, and when you substitute 1 in, you get 0 over 0, and then when you, what did we do here? Oh, I guess we did a little manipulation of the fraction, and when you put 1 in, you get 0 over 0, so then fraction's cleared, 0 over 0, so then we have to go back up here, take the derivative of the numerator again, and why did we get 1 up there? Oh yeah, so I was thinking of negative 1. So then when you plug 1 back in, we all know that ln of 1 is equal to 0, so you get 1 over 2, and so that's the limit. Okay, so I'm at about almost 10 minutes here. Let's see if I can get the other ones in. Now these three are the forms in which you want to think logs. And I'll show you a different way to do this in class. Maybe you like it this way. I want you to give me a heads up on that. Give me some feedback. So you notice that there's exponents. Okay, these are the three indeterminate forms in which we may or may not have a limit. We usually do. It's usually 0. Okay, and most of them are 0, so if you totally get stuck, just pick 0. And then e to the 0 is 1, and I'll show you how that works. So we use this notation here. Let me back up. Take the log of an exponential function, you get the exponent moved out front, and then you can rewrite it as a fraction, allowing you to use L'Hopital's rule. Now, here's how this works. When you rewrite limit as x approaches a of f of x, I'm looking right down here, e to the ln of anything is that anything you started with. So when you put an e to the ln in there, you're still going to be finding limit as x approaches a of f of x, but we'll see how it works. Now, another thing I don't like the way this PowerPoint reads is it doesn't really explain how you get from the ln of the limit to the limit of the ln, but I'll explain that in class as well. But if you can remember that little rule, the ln of the limit is the limit of the ln, and it's pretty easy to show. It's just, it's kind of not really, not something that's just common sense. Okay, but if you remember that rule, it's really helpful in this case. So here's a couple examples. We've got infinity to the 0, that's one of the indeterminate forms. And now, also in this slide, it didn't do that intermediate step where you write e to the ln of something. It just switched the limits and the ln. So really what we did here was it did e to the ln of the limit and then went right to switching the limit of the ln. So what we're going to do here is we're going to switch this around. We're going to actually find this limit right here. Okay, so we're going to bring the 1 over x out front. Okay, then we can see that we can just put the x in the denominator, right? And we get, as x approaches infinity, the limit, or the ln of infinity, goes to infinity. And then x goes to infinity, obviously. And so we can take the L'Hopital's rule applied to the fraction ln of x over x. So we get 1 over x. As x approaches infinity, 1 over x goes to 0. And so what we get is e to the 0, and e to the 0 is 1. So what I would do if I were you, I would go all the way back to this and try to reproduce that problem. Okay, I'm not going to have any practice problems for you guys, so you're going to have to, until you get to class. So anyway, let's try another one. That's the end of the slideshow. Okay, so there you go, the end of the slideshow, and I'll get you, oh man, where's my, uh-oh, I gotta fix this here. I'm just using this for the first time. I have to click done, and then I will see you in the next video.